Serial dilutions are used to accurately make really dilute solutions. They're used throughout science, not just in chemistry, but in microbiology and medicine as well. So let's look at an example. We start with our equation M1V1 equals M2V2. For the first dilution, M1 equals 1 mole and V1 equals 10 mils. M2 we do not know and V2 equals 20 mils because we have already added 10 mils of water to dilute it by half. Substitute in these values and you get 1 times 10 equals M2 times 20. So 10 equals 20 M2. And rearranging means M2 equals 0.5. Now on to our second dilution. M1 equals 0.5. V1 equals 20 mils. M2 we do not know. And V2 equals 40 more because we have already added 20 ml of water to dilute it by half again. Substitute in these values and we get 0.5 times 20 equals M2 times 40. So 10 equals 40 M2 and rearranging means M2 equals 0.25 or a quarter. And finally, our third dilution. M1 equals a quarter, V1 equals 40 ml, M2 we do not know, and V2 equals 80 ml because we have already added another 40 ml of water to dilute it again by half. And substituting in these values gives us a quarter times 40 equals M2 times 80. So 10 equals 80 M2 and rearranging gives us M2 equals 1 over 8, which is 0.125 moles. So after 3 dilutions, the concentration of the hydrochloric acid is 0.125 moles. See, serial dilutions are just as easy as plain old dilutions. All you need to remember working, and you'll fly through dilution questions. There's just one tiny thing more to know about dilutions, and that's how we label them. Let's look at colonies of bacteria for this. So we take 1 mole of our bacterial colony and add it to 9 ml of broth. This gives us a 1 to 10 dilution. If we then take 1 mole of this 1 to 10 dilution and add it to another 9 ml of broth, we now have a 1 to 100 dilution. And if we take 1 more of this 1 to 100 dilution and add it to 9 ml more of broth, we now have a 1 to 1000 dilution, or even just a plain old chemistry experiment. So there you have dilutions. They are very important to many professions, especially doctors. And thanks to the good old M1V1 equals M2V2 equation, they are very simple to calculate.